Good day everyone, I am Wendy Jane P. Lazarte, and in this video, I'll be discussing the topic Define mechanical wave, transverse wave, longitudinal wave, periodic wave, and sinusoidal wave. So first, what is a wave? A wave is a disturbance or vibration that travels through a medium, such as air, water, or solid, or through a space carrying energy from one point to another. In short, wave is a repeating disturbance that moves energy from one place to another. Now, we move on to mechanical wave. What is mechanical wave? A mechanical wave is a type of wave that requires a medium, such as solid, liquid, or gas, to travel. This is because it relies on the particles of the medium to transfer energy from one location to another. Without a medium, mechanical wave cannot propagate or travel. So, a mechanical wave needs or requires a medium to travel energy from one place to another. The medium could either be solid, liquid, or gas. The key point in this topic is, no medium is equivalent to no mechanical wave. An example of mechanical wave is a sound wave in air. A sound wave requires a medium to travel energy from one location to another. The air molecules vibrate back and forth, passing energy to neighboring molecules. This is the key factor of mechanical wave. And in addition, sound waves cannot travel through a vacuum, making it suitable example for a mechanical wave. Next is a transverse wave. In transverse wave, the particles of the medium move perpendicular to the direction of the wave travel. If the wave moves horizontally, the particles move up and down or side to side. So, in transverse wave, the medium moves perpendicular or at right angles to the direction of the wave is traveling. An example of this is light wave or water wave. In this situation, on a surface of water, particles move up and down while the waves moves horizontally, so they move perpendicularly from each other, a classic example of transverse wave in motion. Next is longitudinal wave. In this wave, the particles of the medium move parallel to the direction of the wave. This means that the particles compress, come closer together, and rarefy or spread apart as the waves move. So, in this wave, the wave where the particles of the medium vibrate is parallel to the direction of the wave travel. An example of longitudinal wave is sound wave in air. A sound wave in air, the molecules will vibrate back and forth in the same direction the wave is moving. So, the particles of the will vibrate along the same direction the wave moves, forming a compression and rarefactions. This is the hallmark of a longitudinal wave. Next is periodic wave. A periodic wave repeats its motion at regular intervals, creating a predictable pattern. The wave moves through a space and time, consistently repeating over a fixed period. An example of this is a vibrating guitar string. When a guitar string is blocked, it vibrates and the motion the wave creates a regular repeating and have a constant frequency. All of these are characteristics of a periodic wave, making it a perfect example. Lastly, the sinusoidal wave. A sinusoidal wave is a type of periodic wave that follows a smooth repeating wave pattern, resembling the sine and cosine curve. Is a special case of transverse wave where the motion of the medium is perpendicular to the direction of the wave travel. In short, a sinusoidal wave is one that looks like a smooth continuous wave, just like a sine curve in math. An example of this is a sound from a tuning fork. The wave it produces is smooth, regular, and follows the shape of a sine curve, which is a definition of a sinusoidal wave. Follow-up questions. A slinky wave, when pushed and pulled along its length, is called a... Alright, the answer is a longitudinal wave. Next, a pendulum swings back and forth in a smooth, repetitive pattern, creating a vibrations that can be modeled by a sine curve. The wave generated by this vibration is called... Okay, the answer is sinusoidal wave. And that ends our discussion. I hope you learned something. Thank you for listening.